now. And after this, you will be able to make any program. So I take one example, small example. Like I have one start push button I0. When I press a start push button, a motor should get on for 10 seconds. After 10 seconds, motor should be off. Very simple example. See, I0 is a push button. Q0 is a motor. When we press start push button I0, motor Q0 should get on for 10 seconds. Simple. So how shall I make it? Our problem is we start thinking about all the things, and we start thinking about timer first. I have seen people when they learn timer, they start thinking about timer first. They forget push button and they forget motor. So what I do for any project, initially we used to have flow chart. Yes, no, if, else. But now we don't follow flow chart, but we write down the steps simply. And as we write down the step, you will see how easy it is to make program. So we write down I0 on, Q0 on for 10 seconds. And believe me, if you write down this thing, you will get solution blindly. Like yesterday I told you, you just follow the steps. Here also, you just follow the step, you will get solution. See how. So we have 3 steps. 1, 2, 3. Concentrate, please. Again, we have to follow few steps. Like yesterday I told you, make a truth table, go to the first output, take a coil for it. Like that, we have some steps for these kind of projects, programs. See,
Sir,
what
I
are
have
the...
one doubt. Can I ask?
Yeah, any doubt you ask.
Sir, yesterday you taught us the Codesys software. So as you said, today we can use any other softwares also. So can
Yes.
we use any other simulator for doing this
Yeah.
program?
See, madam, for any PLC software, any brand software, almost every software will give you simulation.
Yes,
So,
sir. Yes, sir.
so we have simulation for all brands.
Yeah. So just now today, whatever we'll be doing, the HMI and SCADA
Yeah.
interfacing,
Yes.
do we require the hardware for that, or it's possible on the simulator?
Some softwares will simulate the things, and some
Yeah.
software will require hardware also.
Okay. So
But
for today's session,
most of the software will be simulated. I have seen.
okay.
Yeah.
So Codesys supports SCADA and HMI.
Codesys Codesys software is for Mesang PLC.
Yeah.
MELSUNG. It is Pune-based manufacturer, but
Company.
now
Yeah.
it is occupied by Mitsubishi.
Yeah.
So uh, this software itself, it has one SCADA or HMI system, you can say. This software
Hmm.
has visualization. So
Hmm.
yesterday I had sent one link, YouTube link. So if you
Yeah.
go through that link, you can learn visualization also. Yesterday, Yogesh
Okay.
did not get time for that. So he
Yeah.
could not do, I think. So that thing
Hmm.
you can learn there. So yesterday you
Okay.
made timer, you made
Yeah.
switches, lamp, all those things you can design in Codesys
Hmm.
software itself, and it can be run.
Okay.
So that
Okay.
thing you can learn there, and further you can contact me if you get any problem. I shall solve that.
Yeah. Sure. Thank you,
Uh,
sir.
okay. So this thing,
So
let us...
today we'll be doing on Codesys only.
No, madam. Today it's another software. Like
Okay.
for HMI and SCADA, we have different software.
Okay. Because we didn't get that link for installation.
Okay, that we will sort out. After session, you text me, I shall sort out.
So we are not supposed to do it right now.
No, right now, Codesys we are not going to use.
Okay. Okay. So we are supposed to just see this demo.
Yeah, see this and make some program.
Okay. Yeah.
Uh,
Sure.
fine.
Thank you, sir. Thank you, sir.
So I told that if we follow few steps, it's 10:26. I shall move fast. So if you have to make such program, what we can do, we can follow few steps. So what are the important things you have to remember? First thing, again, I shall tell you, to switch on NO and to switch off NC. Very first thing, common thing we have to remember. First thing, to switch on NO and to switch off NC. Second thing, whenever we get start signal. Whenever we get start signal, we need to latch that with some flag first. It's compulsory, you consider. It's actually, it is not a rule, but it will help you to make programs so easily. So what we have to remember, whenever we get start signal, that signal should be latched with some flag. Okay, done. Then when we get stop condition, from that stop condition, we have to break latch. When we get stop condition, from stop condition, we have to break latch. Once more, to switch on NO, to switch off NC. When we have start signal, we have to latch that with some flag. Then when we get stop condition or stop signal, from that we have to break latch. Further, I shall add few more things, but let us make this one. Look at the screen, please, everyone. And I hope you will be able to understand the things in easy way. So I0 on, Q0 on for 10 seconds. Now, don't think about Q0. Don't think about timer. Just go to the first step and see this. What is this? I0 on. It means I0 is the start signal. So when we get start signal, we should latch that with some flag. So I shall just follow it. I won't think anything. I saw that it is a start signal, and we know that when we have start signal, we should latch that with some flag. Think nothing. So I have latched it. Now you see one small thing I shall do, and that would be very important. Often while making program, we get confused. Okay, start I have made, but what about this motor Q0? What should be the enable of this Q0? What should be the enable of this timer? This problem, this confusion can be eliminated by following one small step. And you see this important step. From I0, I want answer from you. From I0, which signal we have got here in this ladder? I0 is the start signal. We latched this with some flag. So when we press I0 in this ladder, which signal we get? Tell me, anyone. When we press this start signal I0, which signal is generated in this ladder? Okay, I shall tell you. When we press start push button here, obviously M0 will be generated, correct? And as it is latch, it would be continue on. So M0 will be generated. Now you must write down this M0 here. Now you see, as you write down this M0 here, the things are very clear that from M0, you have to do first thing M0 Q0. Isn't it clear? So you don't need to think what should be the enable of Q0. So first you should do this M0 Q0. It is clearly written that we have to take M0 and we have to take Q0. Done? Done. Now, again, you go to M0 and you see what to do next. M0 and 10 seconds. Isn't it clear? M0 and 10 seconds. So M0 and 10 seconds. Sorry, I should take a time. 10 seconds. Obviously, after 10 seconds, we get a done bit. So that you always use a flag here. It would be good. Don't use output everywhere, because when you make a big program, output should be separate. Because sometimes output will be off, sometimes it would be on. So it will affect your another ladder also if you take it as done bit. So always take some flag here. So M0 you have already used. So M1 is the next flag. Okay, done. Everyone, look at the screen and tell me. After 10 seconds, which signal we have got here? Tell me, please, everyone. In this ladder, after 10 seconds, which signal we got?
M1.
M1. Very good. Very good. After 10 seconds, what have we to do in this project? After 10 seconds, what is the requirement? After 10 seconds, this is the project. After 10 seconds, what is the requirement? What have we to do?
Motor 1 should start.
After 10 seconds, we have to switch off the motor, isn't it? After 10 seconds, we have to switch off the motor because the motor should run for 10 seconds. So obviously after 10 seconds, motor should get off, isn't it? So after 10 seconds, motor should get off. And after 10 seconds, we got the signal M1. It means M1 is the stop signal here. Correct? No. After 10 seconds, you have to off the motor. And after 10 seconds, which signal you have? M1 you have. So M1 is the stop signal. And I told when you get stop signal, break latch. Here is the latch. So break the latch. And everything will be off. As your latch is broken, everything will be off. Done. Ask me if you have any doubt in this program. Then I shall go for next program and then we shall come to the HMI. Tell me if you have any confusion in this program. Okay, I shall proceed. Done. So once more, the steps I shall tell you. To on we have anode and to switch off we have NC. To switch on we have anode and to switch off we have NC. When we have start signal, we have to latch that with some flag always. When we have stop signal, from that we have to break latch. One more thing I add here. When you get last signal in your program, break all latches from that. When you get last signal in your program, from that you have to break all latches. In this program, M1 is the last signal, isn't it? M1 is the last signal. Why? How? Because after 10 seconds, you have not to get anything on further. Correct? After 10 seconds, you have not to get anything on further. After 10 seconds, you have to switch off the things. So M1 is the stop signal. So when you have stop signal, break all latches. We have one latch in this program, so this will be broken. If you have many latches, all latches will be broken from the last signal. But if it is intermediate signal, do not break latch from this. For example, after 10 seconds, switch off Q0 and switch on Q1. Do you understand? After 10 seconds, switch off Q0 and switch on another output, Q1. In that case, M1 is not last signal because you have to get something on further. In that case, M1 will not break latch, but it will break this Q0. It will break this Q0. So always break your latch from last signal. Okay, now I shall come directly to our project program. I shall directly come to the project program. So what is the program here? When we press start button I0, Q0 should get on for 3 seconds, correct? 3 seconds. After 3 seconds, what should happen? After 3 seconds, Q0 should be off. And Q1 should get on for 5 seconds. Correct? After 5 seconds, what will happen? After 5 seconds, sorry for bad handwriting. After 5 seconds, Q1 should get off and Q2 should get on for 7 seconds. Okay, done. So we all will make it together. Okay, look at the screen and see, you will be able to make this. It's very easy. It's very easy. Don't be worried about all steps. Start from first one and interact, please. Please have some interaction here. So you need to tell me, everyone, tell me, I0 is the start push button. So what should be our first ladder? I0 is the start push button. What should we do first? When we have start signal, what we do? Tell me, don't feel any hesitation. When we have start signal, what we do? And oh, and I told when we have start signal, we have to latch that with some flag. It's okay. So let me latch it with some flag. M is the flag here. M0, correct? Important thing I told that put this M0 here. It will help you to make next ladder easily. So M0, tell me what is the next step? M0, Q0, isn't it? It's very clear. I am not thinking about everything. And I'm not thinking anything. I'm just following the things. M0, Q0. So I shall take here. M0 and Q0. Done. Think nothing. Just follow. Next, from M0, what to do next? M0 and 3 seconds. See, it's very easy. M0 and 3 seconds. Okay, done. After 3 seconds, we shall get one done bit, that is M1, correct? So text me and answer me actually. After 3 seconds, which signal we got here? After 3 seconds, which signal we got? After 3 seconds, which signal we got? Tell me. Tell me everyone. After 3 seconds, which signal we got?
Q1 will be off.
Q0 will be off actually. So
Q0,
after,
sorry. Q0
yeah.
will be off.
So after 3 seconds, we got M1. You see, this is important. After 3 seconds, you have to do many things. Let it be. But first thing you need to search is after 3 seconds, which signal we got? We got M1, correct? So you must write it down here. Then it would be easy. Now it's very much clear that from M1, switch off Q0. And M1 is not last signal because you have to do many things for it. So M1 is not last signal, break Q0. So don't break latch, break Q0, correct? So here I break from M1, correct? M1 Q0 off. This we have finished. Next, M1 Q1 on. So let me do this. M1 Q1 on. And I'm not thinking about everything. I'm just following the steps. Again, M1 and 5 seconds. Let me take it. M1 and 5 seconds. After 5 seconds, again, we have one done bit, that is M2, correct? So after 5 seconds, we have M2. M2 is again not a last signal because we have to do many things. So M2 has to switch off Q1. Listen and answer. M2 has to switch off Q1. So where should we put the NC? M2 has to switch off Q1. Where have we to put the NC?
Between M1 and Q1?
Yes, exactly. Very nice. You understood it. So here you have to put it. Don't break latch, but you break Q1 directly. Nice. Now, next from M2, what to do? Q2 should get on. So M2, Q2. Let me do that. So it is M2 and Q2. M2 and Q2. Done. Now, one more thing is left, M2 and 7 seconds. So what to do? M2 and 7 seconds. M2 at 7 seconds. M3 we shall get. Now you see, after this M3, we have not to get anything on, correct? No? M3 is the last signal in this program. After M3, you have to get the things off. So M3 is the last signal. When we have last signal, what we do, we break all latches. So we have only one latch here. So from last signal M3, we break latch. Done, correct? So just follow the steps and you will get solution. Important thing is here, writing this thing, writing this thing, writing this thing. If you write it here, it would be very easy. If you don't write, I'm very sure that you will make some mistake. So just follow the steps. The steps I shall text you further. I shall copy and will paste somewhere. I have that in my PDF. For now, I shall send you this program. And now I shall go for HMI. Okay. I've said that it will reach to me. So it is clear. So we have made one program. Now we go for HMI. Fine. Here. So that program, the same logic I have made here in Mitsubishi software. And Mitsubishi software, I have used here GX developer. So GX developer or GX works you can use for making program, used to make program for Mitsubishi. Here I have already made to save time. So here also you can see like codices, they have given NO, parallel, NC, NC parallel, coil, many things they have given. So just pick and place, do the things. Now we need to select some data from here. What are the data? Okay, I shall come to this further. First, let me give you introduction to HMI. Then I shall come back to this program. Now you see. Okay, look at this screen. So we have to learn HMI and SCADA. What is this HMI and SCADA? We shall have some talk first. With PLC, you can make one machine automatic. Obviously, you can make machine automatic. Everything will go on very nicely, no problem. Production will go on. But with PLC only, one automatic system will not be that flexible, will not be that user-friendly. Because for a good machine, there are two major requirements. First is monitoring of data. Monitoring of data. Data means the addresses you have used in your program, correct? So we need to monitor the addresses, status of addresses, what we have used in our program. And it is very important. Why? I shall tell you. In your machine, you will have many sensors. Some sensors will be inside the machine where you cannot reach, you cannot see that. But you need to know whether it is on or off. So you need to monitor the status of sensors. You need to monitor the status of all outputs you have used in your machine. Might be you have 60, 70 outputs. You need to monitor the status of all outputs together. You need to monitor the running value of timer. A motor has been running, it has to run for 1 hour. Now, how long it has finished yet? We need to monitor. Just by seeing PLC, we cannot see the status of timer. We need to monitor the present count. We need to monitor the count value or the accumulator of counter. In a good machine or in a good industry, in process industry, we will have many analog sensors, temperature, pressure, flow, level. So we need to monitor the status of temperature. We need to monitor the present status of level in a tank. And most of time, the furnace, the boiler, the tank will be away from your workstation. So you are not going to the tank or to the furnace all the time to see the status. So we need to monitor it. If we are not able to monitor all these things, we won't be comfortable to work with the system. The machine will run automatic, but we won't be understanding what's the present status of the production or the machine or other things. So we need to monitor the status of addresses we have used in our program. Done. There is one option. The option is you can connect your PLC to your laptop. That I will show you here. Practically, I shall show you how we monitor in software. So you can connect your PLC to your laptop, open your PLC software. In software, you have option monitor mode, and there you can monitor the status of all addresses. Timer status, counter status, temperature, pressure, sensor, everything you can monitor. But practically, it is not possible to use PLC software to monitor the status of data in industry. Reason. First of all, one operator has to operate the machine. One operator needs to know the status. Operator does not know how to communicate PLC with laptop, how to receive the program, how to monitor the things. Another thing, in industry, yesterday you made program, I think, of 4, 5, 6, maximum 10 ladders you have not made. In industry, it would be 5,000, 6,000 ladders. So among those many ladders, how will you monitor the status? You will scroll up, scroll down, and status will be changed. So practically, PLC software we cannot use to monitor the status of addresses, or you can say the status of machine. Clear? Second requirement. So monitoring, you understand. Second requirement, we need to change some numerical values without changing program. So we will have many timers, we will have many counters, we shall have many temperature, pressure, level, preset values. And as per our requirement, we have to change the value of timer. For one product, the motor should run for 1 hour. For another product, the same motor, the same program should run for half an hour. For next product, the same timer should run for 15 minutes. So every time if you are going to make modification in software, then you have to stop the machine, receive the program, make changes, download to program, download to PLC, or make online edit. It will take time, and one person will be required for it who knows programming. One operator cannot change it through program. So this is important. For a good flexible machine, we need to give it option to change some numerical value through some interfacing devices without changing program. So that also you understand that you need to change preset value of timer, preset value of counter, you need to change preset value of temperature. Preset means the set point of level, pressure, or whatever. So two major requirements you understand. So first was monitoring of data. Second was controlling of data, that you understand. And these both things can be done through PLC software, but I told you practically it is not possible to use PLC software all the times to monitor and control the status of machine. I hope you understand. Okay. Now HMI, you can see, I shall show you on screen. See this. I have no authority to use a note, I think. Okay. So you can see here, HMI, we have operator panel and we have touch panel. In simple, on some HMI, you will have some hardware key, and through those key we operate it. And some HMIs will have only touch panel, only screen. You won't have any key on that. Through software, you need to create key. It is like your ATM. In some ATM, you operate through keys, and you operate in some ATMs, you operate through screen itself. So such kind of thing you have in HMI hardware also. You can have some HMI which will have some keys. You need to configure those keys. And generally nowadays we use touch panel, and touch panel will have just one screen, and the keys, other keys and other things you need to create through software. Okay, done. Next, this thing you see. HMI will have, it is the back side of HMI. HMI will have, I think it's better I show you on whiteboard. It's better. See here. So one HMI, if we have, behind any HMI, first of all, you will have its power terminal, positive, negative. Most of time, it will be 24-volt DC. So from one SMPS, you have to give it power supply 24-volt DC. It will be powered on. Then minimum, I have seen minimum one COM port also, but generally it won't be one COM port. Minimum 2 COM ports you will have. One communication port will be for your computer. That is your programming port. You can send your design, whatever you make in software, whatever design you make in software, HMI software, that design you have to send to HMI. And if you want to receive some existing design of HMI, that also you can do. So during that time, programming port we call it, during transferring the data, you have to use this. During transferring program, you say, you have to use this COM port. Otherwise, it would be open. Another port is your interfacing port, which will be always connected with PLC, always, so that anytime you can monitor and control the data of PLC. But few things you need to know interesting about HMI. Often in industry, each machine will have one HMI. Each machine will have one HMI. But it's not like that HMI can control only one machine at once. It depends on its number of COM ports, communication ports. If you have 2 communication ports, means 2 PLCs can be controlled through one HMI. If you have 3 communication ports, 3 PLCs can be connected to one HMI. But in industry, generally they don't do. They use one PLC, one HMI, like that. But I have, in my lab, I have gone through the interface of multiple PLCs and it was working. So it depends how many COM ports you have on your HMI, those many PLCs can be connected. Fine. Next thing. Now you see some important thing. What are the use of this HMI? What is the use of HMI? What are the importance of using HMI? First thing is monitoring of data that I explained. We can monitor the status of all addresses. Second thing is controlling of data, means changing numerical value. I told you. Third thing is data scaling. This is important, you see. Data scaling. Yesterday you used timer in Codesys software and you have used ET. And in ET, in accumulator, when you were doing login run and timer was running, I don't think you noticed that accumulator was showing you 1, 2, 3, 4, 5, 6. It was showing you the time. But it shows time in millisecond. So for 1 second in Codesys, for 1 second, it will show you 1000 because 1 second will have 1000 milliseconds. And for 5 seconds, it was showing you 5000. But in HMI, it should not be like that. If I have to show 1 second, 2 second, 3 second, 4 second, 5 seconds, then why should it display 1000, 2000, 3000, 4000, 5000? So we have option to scale that data. So we have option, we can divide that by 1000 through HMI. We don't need to do that in our program. So in HMI, we have option, whatever value you are getting from PLC, that can be scaled by some arithmetic operation. Either it can be increased or can be decreased. So that is scaling. In Mitsubishi, what we shall use here, in Mitsubishi, for 5 seconds, it is 50. It is multiple of 10. It depends on the time base. Time base, I cannot explain now. I don't have time to do that. So for 5 seconds in Mitsubishi, it will display 50. But what have I to do? In HMI, I have to display 5 only. In PLC, it will do 50. It will show 50. But in HMI, I don't want to display 50. I want to display 5. So I shall scale that accumulator using HMI feature, scaling feature. And that is in SCADA also. Fine. I think it's better. This last thing, it will take time to explain. So let it be. I won't explain this thing. So it is saving number of PLC input terminal. That if I get time lastly, I shall tell you. Because first my task is to finish HMI because I have to do SCADA also. And it's already 11 o'clock. So that you understand. So 3 things you understood, no? Monitoring of data, controlling of data, and scaling of data. These 3 things we do from HMI. Don't be worried. I shall show you the things practically here, how we work with HMI once you learn today. And if you go through its video again, you will be able to work with another brand also. Some parts I shall share, but I cannot share this PDF because this is from my book and I have agreement with Amazon that I cannot share my soft copy. So I shall share some parts. I shall share. I request you people. You are from colleges. You do one favor. Ask your library to buy my book, and then you use. You don't buy, but your college can buy. I think. In this book, you have 110 PLC examples, and those steps I have given in this. Everything about industrial automation programming I have given in this book. Even HMI, SCADA, drive, analog, PID, everything is there. So you please ask your library, college library to purchase it. Okay, we'll proceed. Next Tuesday. Next Tuesday. Fine. Once everyone text me, did you understand those 3 things? The feature of HMI, why we use monitoring of data, controlling of data, and scaling of data, that you understand or not? Is it clear? Text me, please, everyone. Then I shall go for its practical interface. Is it clear up to now? Only 2-3 people are listening, it seems. Okay, now I go for next. Some people feel hesitation to text and all. Now I come to this program. So this is your program, what you have sent to PLC. I can show you here. I have connected, I don't know whether you can see the system or not. Photo I had sent you know, my laptop camera is not that good. I'd like to show you a system if it is, see, it's not very much clear, but this is PLC. This is PLC and indicators you can see red, yellow and green. I have connected to PLC output and here I have push button, stop push button, and this is start push button, and I have one proximity sensor connected, metal detector, and this is photo sensor. I have not connected actually because it would be a big program there. Then you can see if it is visible. This is SMPS, switch mode power supply, and here it is HMI, human machine interface. So when I shall connect the things, I shall show you this. Done. So first of all, now we are on practical things. So first requirement is we need to send one program to PLC, correct? First requirement is you should send your program to PLC. Let me send that. Here is the program. So I hope you can see we have 26 steps in this program. So in this program, you can see in Mitsubishi, input address is X, output address is Y, timer is T0, K30, K. This I need to explain. In Mitsubishi, your timer you take in coil, and timer is T. First timer is T0, then second timer T1, T2, T3 like that. And you have K30 for 3 seconds. I told you multiple of 10. If you want 5 seconds, then K50 it will be. K denotes decimal. Okay, done. So in a timer, we need to find out 4 parameters. Enable, this is the enable, no problem. Preset value, this is the preset value. Now accumulator and done bit. Accumulator and done bit is its address. So this is only your done bit, means after 3 seconds, you don't need to take a flag here, but you can directly use NC of T0. T0 you can see. So T0 itself is the done bit. So you can put its address. In previous program, you have seen I have taken one M1, M2, M3. So instead of taking M1, M2, and M3, in Mitsubishi, you can use timer address directly. Okay. Accumulator, the running value ET, it is also T0. So when timer will run, it will show you the running value here. So T0 is its accumulator also. So preset value and accumulator, these two are required for timer, for HMI and SCADA. Okay, done. Now you see. So let me show you very fast how we download. This is the communication part, transfer setup. I have connected my PLC to this laptop through COM port number 3 that we can see in device manager. Then we see the connection test successfully connected, and my PLC is FX2N CPU. Okay, now okay, and I go to online, write to PLC means send to PLC. Write to PLC. Here I select main. After selecting main, how many steps I want to send? I want to send only 26 because we have only 26 steps program. So why to send all? and execute. And you see how fast it will download your program. Look at the screen. Look at the screen. See this. After this, it will send your program to PLC. Yes. See, it is done. So your program is sent to PLC. Already it is gone to PLC. Okay, done. So programming part is over. Now we need to collect the data from this program. So what are the data? You note down, please, everyone. Note down. I shall ask you. Write down and make it fast, please. First, X0 start. Write down X0 for start. Note down because I have to show this further. So I shall ask you. I'm not noting down. You note down X0 start. Make it fast. X1 stop. So all these things we have to display in HMI. X0 start, X1 stop, X2 sensor, Y0 red, Y0 red, Y1 yellow, Y1 yellow, Y2 green. Done. Next, we have 3 timers here. So write down PV1 means preset value 1. No need to write down big name. So I'm saying PV1 preset value 1. So PV1 D0, PV1 D0, PV2 D1, PV2 D1, PV3 D2, PV3 D2. Okay, done. Now you write down accumulator. Just write AC accumulator. AC1, AC1 T0, AC1 T0, AC1 T0, AC2 T1, AC2 T1, AC3 T2. Note it down. Done. Okay, so these are the data we are going to configure in HMI. So here you see timer preset value. Here timer preset value is K30. If it is K30, we won't be able to change from HMI SCADA. So we need to give some variable address where we can vary the value. In Mitsubishi, variable address is D0. So for next timer T1, it is D1. So I shall make it D1. And third timer D2. Done. I don't need to send the program again, but I can do online edit. So I go to convert online change. So convert online change means without stopping your machine, you can make changes. So this is online edit. I have done this. I have done this. Okay. So I told you, no, you can see the status in software also. In 1 minute, I shall show you the present status in software. So I do here monitor mode. In software, PLC is connected to my laptop. It is communicating and I go to the software monitor mode. And I can show you the status of X0. Look at the screen, please, everyone. X0, you see. If I press X0 push button, just a minute. SMPS we need to switch on. So X0, you see. Can you see X0? It will be blue. Done. So it is monitor mode. You can say you are monitoring the data. And sensor status, X2 is my sensor. You see the status of sensor. This is metal, and this metal I should put to that metal detector. You see X2. Can you see? X2 is on. X2 is on. Done. So this is your monitor mode that you can do through software, but we have to do from HMI. Now I go to HMI. Fine. I hope you can see this. I hope HMI screen is in front of you on your screen. This is the software. I have already designed the things here. What I have done, I have taken a push button. I have taken start push button. I have taken stop push button. I have taken here preset value 1, 2, 3. Here it is, accumulator 1, 2, 3. And this is red lamp, yellow lamp. In HMI, we have feature that we can create multiple screens. So I have created 2 screens. This is the first screen and another is this one. Some data I have kept here. So I shall show you, we can switch the screen.
Sir, your audio is not clear.
I'm sorry. Is it clear now? Can you hear me now?
If you comfortable, you please remove your headphone.
Is it so? But I think it would be echo after that. Is it okay?
Yes, sir.
You contact them. Okay, so I hope it is clear. So here I have shown you start push button, stop push button. Then we have preset 1, preset 2, preset 3. Here we will change the value. And this is accumulator 1, accumulator 2, accumulator 3, red lamp, yellow lamp, green lamp. Okay, let it be. So I shall just show you how I designed all these things. So I shall take example of 1 push button, 1 preset, 1 accumulator, and 1 lamp, and you will understand how we do this. And then I shall download this to HMI and will show you the interface. So for HMI screen development, we first open HMI software. For different brand, you have different software. This is Delta HMI. So for Delta HMI, it's DOP soft. For Delta HMI, it's DOP soft. So I have already installed and obviously it is open here. Now I take one new file. Look at this screen, please. Take a new file. And the procedure is almost same for all brands. So as we take a new file, very first it asks, select your HMI hardware. So HMI hardware name will be given behind HMI. Will be given behind HMI. You cannot see this here clearly, but here it has been written. Here it has been written, and it has been written DOP B07S415. So I shall just select that. Here I need to select, these all are Delta HMI hardwares. So I have to select B07S415 here, B07S415. So for any brand, you have to do all these things. Next, we do next here. And then we need to select COM port number. This HMI has 3 COM ports. So we have to select which COM port we have to use to connect our PLC. I have used here COM port number 1. By default, it is COM port number 2. I shall remove it. I have used COM port number 1. So I shall connect COM port 1. Now, important, you have to select your PLC hardware. So first you have selected HMI hardware, then you have selected the COM port number, and now you have to select to that COM port which PLC hardware you have connected. So by default, it will give you many branded PLC name. If your PLC name is not here, you can contact the company and can take the driver file and keep that in your laptop. You can browse it. Now, my PLC is Mitsubishi. Here you see Alan Bradley is there. Mine is here, Mitsubishi. So I have to select FX2 and CPU. So I have selected here FX2 and CPU. I hope you understand. Make it finish. So any brand of HMI software you open, first you select HMI hardware, COM port number, and then you select PLC hardware. That is it. Then the screen will be open. On this screen, you have to take all your things like push button, preset value, accumulator, then you need output. See, I shall show you how we take this. So this is button actually. On your screen, look at the screen. This is button. There are many types of button. Mine is momentary. Momentary means push button. Momentary is the push button. Set will be, alternative will be your toggle. Here it is momentary. For push button, it is momentary. I have taken momentary. Very fast, I shall show you all the things. Double click. Now you have option. You have two options. One option is you take two colors. Initial color, after on color, and give address. So when you press, it will change the color. You will understand, okay, it is pressed. Another option is touch screen HMI will give you library. In library, you have been given many designs. So ready-made pictures you have, you can select that also. Let me show you the picture here. So you can see here, look at the screen. It is state. 0 means off state. 1 means on state. So on 0, in off condition, I want a picture. I shall go to take a 3D button. And in 3D button, ours is start push button, green one. So I take, this is the button when it is not pressed. Stretch all. See, so in 0 state, in off state, it will show you this button. In 1 state you go. In 1 state, again picture, 3D button. It is the pressed one. So select this, stretch all, and you see. So 0 state and 1 state. So you have push buttons. You have taken 2 pictures. Now you go to main and select their address. Select address. So address here you see here address. Tell me, text me, everyone, what is the address of start push button? What is the address of start push button you have noted down? What is the address of start push button you have noted down? I have made you know. Tell me. Start push button address is X0. X0. Enter. Done. So what we have done here in this button, momentary button, we have taken 2 pictures, 0. Be changed in another software. They can give another name. Here it is indicator. Here also you have 0 state and 1 state. In 0 state you can take a picture. I take here lamp 2 state. Suppose you want yellow lamp, then this is the off lamp. Then you go to 1 state, and there you have to take another picture. 3D 2 state. This is the on one. Done. Next, you have to go to main and you have to give the address for output. For yellow, it was Y2. So here you can give Y2 and that is it. So it's very easy to draw the things. It's very easy. It will First, it will take time to learn the things where we have the elements. And then it's very easy. Then you can copy paste and can change the picture and address. Fine. For a preset value, they have given input numeric entry. So numeric entry you can select for changing preset value. Here you can just give your address, that is D0 we have here. So here we have to take D and 0. It will be done. For accumulator, for displaying anything, timer value, counter value, temperature, pressure, flow, anything. To display, you have here numeric display. And here also you just double click and you can give your address. Address is T0. So you can select T and 0. See, important thing is here, when you select address here, in address you can see they have already shown M, X, Y, T, C, D. These are addresses for Mitsubishi. And it will come when you select your hardware. When you take new file, you have to select your hardware. So when you select hardware, then only it comes. If you select Mitsubishi, Allen Bradley, then address will be different here. For Siemens, address will be different here. So it will show you the related address as per you have selected your hardware, PLC hardware. Okay, done. So in this way, we take all these things. Now, very first, let us move to the screen I have created already. Here. So I have shown you how to take all these things. After making all these designs, giving addresses, now you have to send this design to HMI. And again, it's very easy. Here on HMI, they have given one port to communicate your to connect to be connected to your computer. So I have connected this HMI to my laptop through one USB port. And after that, you have to simply send this program to HMI. How to send program to HMI? Tools, download all data. Tools, download all data. Because I have not connected the cable to laptop. That's why it is showing communication error. I had connected Mitsubishi PLC. So now let me connect that cable. So this is the cable for HMI programming. So this I connect to USB port. Now I go to tools, download all data. Now you see it is being downloaded. It is being sent to HMI. And it is done. It is done. Okay, so you understand up to this? I hope you understand up to this. So you can see, is it clear? So you can see whatever we have designed, it is on this HMI now. It is on this HMI now. Now, we need to connect this HMI to PLC. We need to connect this HMI to this PLC. Let me clarify a few things here. What have we done yet? What have we done yet? Let me tell you. We have downloaded program to PLC, correct? We have downloaded program to PLC. We have designed one screen on HMI. So we have sent one design to HMI. Now connection, you see, it's very easy. On PLC, you have communication port. Here you have selected on HMI, you have selected COM port number 1. So from programming cable, PLC programming cable, you have to simply connect your HMI. That is it, nothing else. No other cables are required. So your PLC programming cable, one end will go to PLC and another end will go to HMI. So one end I have already shown you here. Here. This is the one end of communication cable. It has gone to PLC, you can see. And this is the another end. This end will go to HMI. So let me connect this to HMI. And you can see on the screen also, the connection is very simple. So now I connect this to COM port number 1. I have connected it. So it is connected to COM port number 1. So here you can see COM port 1, 2, 3. There are 3 ports, and this is the power terminal. 24 volt DC we have given here. So COM port 1, 2, 3. I have selected COM port number 1 from software. So here we have to connect to COM port number 1. Now let me show you the things. Okay. So is it clear? I think it's very dark. Let me off the light, I think, then it would be visible. Stop sharing. No, still it is not visible. Okay, see, whatever you can see, actually it's having a lot brightness. Somewhat it is visible, but those numbers are not visible. It is visible now a bit. So you see, when I press the start push button on machine, so I am operating machine here. When I press the start push button, you can see all these lamps are fluctuating. Why? Because I have not given the value of timer. So value of timer first I need to give. So here I touch. It is not visible because of brightness. How can I show you? So one numpad has come. There I have to give the number. Like I want here 3 seconds, so I enter 3. For another, I am giving 5 seconds, and for next, I am giving 7 seconds. Entered. So here I have entered the value. How can I show you? It's so bright. It is not visible. Actually, I have given some value here. So 3 seconds, then 5 seconds and 7 seconds I have given. Now, if I press the start button, first red lamp should get on. You can see the red lamp is on there. And here also, on main screen also, it is, you can see green lamp is on, and on HMI also it is on. After that, red lamp is on. Then yellow lamp is on. Fine. So in this way, you can see whatever is going on on machine, you can monitor the things here. Actually, the timer is also running here, but I don't know how to show that. The timer is running here actually on. I'm sorry, I can't show you. It has a lot of brightness. So here, the timer value, you can see it is running actually. So one more thing I can show you. Yet you have operated the machine from push button. You can operate it from HMI also. So first I stop the machine and I can operate from this green push button here. See, as I press, red lamp is on, then yellow lamp is on, and then green is on after 5 seconds. See here, I can stop it from here. Stop and start. Stop and start. And let me tell you, this is the real hardware we use in industry. It's not like we are take rest and ask question about HMI, and then finally I shall finish SCADA also. SCADA also I shall show you in real time. So if you have any question regarding HMI, you ask me, please. But because of brightness, I could not show you the things in proper way. But I hope you got the idea of HMI. So ask some questions, please. Any question? Anyone? Any question? If you have, you ask me, or else I shall go for SCADA. Okay, so I shall proceed for SCADA now. So one HMI, you can see on HMI, you can take all these designs. These are available in library. These all things are available. You can design all these things on HMI screen. Now, supervisory control and data acquisition. Supervisory control and data acquisition. What we did from HMI, we do the same from SCADA also. First thing, in simple. Supervisory control and data acquisition is also an interfacing kind of thing. The question will be, if we have the same work from HMI and SCADA, then what is the difference between these two? We have difference. 3 differences we consider basically. First one is HMI is a hardware. I have shown you. HMI is a hardware. Whereas SCADA is a software. So SCADA, there is no hardware called SCADA. SCADA is a software like other softwares. What we install in our computer or laptop. Like CAD you have, CATIA you have. All those softwares you install in your computer laptop, and through that you make designs. Here SCADA is also a software which will be installed in your laptop. First difference you understand. And SCADA is not a controller. Individual SCADA software cannot control the things. SCADA is just to monitor and to control the data of controller. Without controller, SCADA has no use. Second thing, HMI has less storage memory capacity, and SCADA has large storage memory capacity. Obviously, your computer hard disk can also be used, cloud can also be used. So you can store more and more data, that is history record also, we say. Then third important thing about SCADA and HMI difference. HMI is used on machine level. It means in industry, each machine will have one HMI. Each machine will have one HMI. SCADA we use on complete industrial level. SCADA we use to monitor and control whole industry. Complete industry can be monitored and controlled from SCADA. SCADA we don't use in small industries. We use that in big industries, which is spread in large area, where it is not possible to go to each and every individual machine and check the status. So SCADA generally is used in big industries, which is spread in a large area, like cement industry, cement plant, power plant, automobile, car manufacturing industry, it will be in kilometers. Pharmaceutical, oil and gas. In smart cities also they are using SCADA. In municipal corporation now they are using SCADA. So everywhere, when your system is spread in large area and you want its monitor and control also, you have to go through SCADA software, supervisory control and data acquisition. So about SCADA, theoretical things you can find many in internet, in YouTube. I want to have discussion about the development of screen. Like how do we develop one SCADA screen in industry? And what are the important things we need to remember when we work on any new brand of SCADA software? When you have to work on SCADA software, you focus on three things, or you can say you search three things in that software. First part is your design part. So for design, you need to search few things. I hope I have written here you see. So you can see, first is your design part. That is also called mimic also. In industry, we call mimic also. That's screen development. Okay. Second is your driver selection and configuration. Third is tag creation and configuration. First, we have to discuss is about design part. In design, you have to search 4 or 5 things. First, how to design a switch. You search to design, you search button or switch if it is available. You search that. If you search that and you configure that, you can copy paste and can design the same for many inputs. Second thing, you need to search how to create one output, how to design one output. Third thing you need to search is preset value, means changing numerical value of timer, counter, temperature, pressure, anything. So one thing you have to search to change numerical value of any data, that is preset value. That can be called set point also somewhere, or numeric entry also. You have seen in HMI it was numeric entry. So you have to search all those things. So switch, output, preset value. Next, accumulator you need to search, because you need to display the status of timer, you need to display the status of counter, you need to display the status of temperature of a furnace, a boiler, you need to display the level of a tank. So you need to search display. So only one display you search, it can be used for all timer, counter, temperature, pressure for all the elements. Next, one more thing you need to search is in design part, text display, some message display you can say. One simple example if I give, I have used one sensor here. I want to show the status of sensor on SCADA, whether sensor is on or off. So text display will be required. Sometimes we need to flash some error. So for that also text display will be required. So 5 things in design you have to search. First is your button, input, then output, preset value, accumulator, and text display. So design work will be over with this. Design depends on you. From library you select pipelines, tank, other things. Everything is available in library. From library you pick and place. And you have to give at you have to focus on those 5 things. Then it is driver selection and configuration. Driver selection and configuration, try to understand. In industry, you have many machines. And each machine has one PLC of different brand. It can have different machine can have different brand of PLC. So through some communication protocol like CC link, like Ethernet, or Profibus, Profinet, or any other OPC server also we use. So using any communication protocol, you connect all your PLCs to one computer and distribute the data to the SCADA software. So take one example, we have to connect, suppose 3 PLCs, Mitsubishi, Allen-Bradley, Siemens. So I have brought Mitsubishi cable, Allen-Bradley cable, and Siemens cable. Individual I'm talking about. Means if you don't have higher communication protocol, then directly you bring the things, bring all 3 communication cables and connect to 3 USB port of your laptop. So now you have to configure in SCADA software. This is important. Without this, you won't be able to. You need to configure which brand of PLC you have taken and through which COM port you have taken. So this driver is your PLC brand. So in SCADA software, by default, they will give you some PLC name, driver will be by default. And if it is not there, then you download the driver from internet or you take from the company, keep that in your laptop and browse it. So I will have to select drive. We will go to the driver, take new driver Mitsubishi. Again, new driver Allen-Bradley, new driver Siemens. So 3 drivers we have selected. After selecting these 3 drivers, you need to select the communication port through which COM port you have connected your PLC. Suppose Mitsubishi COM port 1, Siemens 3, Allen-Bradley 2. So you can go to the driver and configure COM port number. So this is your communication part. So first is your design, second is your driver, and what is that? Drivers selection and configuration. So that is PLC selection and COM port configuration. Done. Third thing you need to do is, it is all these 3 are important. In HMI, you have seen I did double click, went to main, and I have given X0 directly. Input address I have given directly, output address directly, preset directly. In SCADA, we don't give direct address like X0, Y0, D0, T0, no. In SCADA, we need to create tag for each address. The addresses I had made you note down, but I think no one had noted down because no one replied me during HMI screen development. So I had told you X0, X1, D0, D1, D2, T0, T1, T2. For each address, I will have to create a tag. And then lastly, we can go to the design and can give the tag, or we can add the tag. That is the addressing part. So mostly we do addressing thing lastly. So first we design the thing, then we configure the drivers, then we create the tags, and lastly we add tag to all designs, then it will start working. So in 10 minutes, I can show you the SCADA screen and I can show you all these three things there. Again, you can see the program, what I had made, I have shown you here, but this is not required because our program is a bit different. So I shall go to the SCADA software directly. I'm using here Ellipse SCADA, Ellipse, ELIPSE here. Actually, I had created this last night, only I prepared all the things. So I shall just show you how I designed the things. Will not go in detail because it takes time. SCADA takes time. SCADA design will take time because we have many data, we have many procedure to follow, but those three things only: design, driver, and tag. It takes time. All these three things take time. So first thing you see, here also you take a new file. After taking new file, you can start creating, making the design. So in design, you see, first I have taken this start button, you can say, and stop button. For that, they have given here button. So when I take the button, I can double click. If I want to give name, I can go to frame and here I can give name. Those color and all you can do further. And nothing else, just name I have given. If you don't want to give name, then nothing you have to do. You have to just double click, and this you can select if you want. This you can select. It depends on your software how they have given it. Again, for stop, I have taken the same. So button, you understand. For preset value, you see changing value, changing numerical value. So for that, they have given the option set point. So here also you just take this set point, do nothing. Lastly, you have to give the tag. Then I go for display. You see, this is display, that accumulator. So for accumulator, they have given here display. I have taken this, just design it, do nothing. Lastly, we have to give address, that is tag. And then meter also you can take from here. You can take meter, nothing to do. It will also run. And output you see here. This is the thing which will run. Output, how we take here, this is animation. It is like picture in HMI. So I have taken this. When I take this, I do double click. After double click, I go to zone. And here I add two pictures from library, or I have downloaded from internet. I have kept on desktop, that I will select. So from here, I select two pictures will be selected here. So two pictures I have selected. So one picture will be default. Default means zero state, off state. Another picture will be your on state. So on state is one, no. So I have given here one and so on state one. So zero state, one state, two pictures you have to take. Blink you can give here. So this is SCADA feature. Here on hardware, it won't blink, but if you want to blink it here, you can do that. So blink you can give. So this is your output. So like that, I have taken all these outputs. So here, red, yellow, green, any design you can select. Then I have taken here sensor also. Sensor, that is text display. Here you see. Text. In text display, what I have done, you see, I have to go, it is like output. Go to zone, add two zones. Like this, you can add two zones. So first zone, I have written my message. My message is sensor off. And I have made it default, zero state. So initially it will show me sensor off. Then I go to second zone and I write my message, sensor on. So when will it display sensor on? When my X2 status will become 1. So I have given here 1 and 1 minimum maximum. So when X2 will become 1, it will display this message. When it is off, it will display the default one. Then that is your design part. So design depends on you. Fine. Now, second thing, let me show you. I have 5 minutes. Second thing I can show you, that is your driver. And third thing is tag. So in driver, you see, I have gone to application organizer. See, the steps can be different, but driver is available in all SCADA software. So you can search driver. Tag is also available everywhere. You can search tag. So application. Here you see all these things are available. Driver you see. Driver I have taken Mitsubishi because I have Mitsubishi PLC. So Mitsubishi FX PLC I have selected it. In configuration you can see I have given COM port number 3 because I have connected my PLC to COM port number 3 of this laptop. Done. So driver is selected. So in driver PLC and COM port number. Easy. Now you go to tag. In tag already I have taken these many tags. So how we take this? We go to tag, take new tag. There are many types. PLC tag. Okay, in PLC tag, how many tags you want? It depends on the number like X0, X1, Y0, Y1, Y2. So count that, how many addresses you have. Those many tags you take from here. Then you go to each tag, you can give the name, you can give here address, that is it. If you have timer, you see accumulator. I have scaled it also. So here you have scaling option. You can scale this also and give the address. That is it. Finally, you go to the design, each design, double click, and you can see here. Can you see this? Here, tag. In tag, here you have the tag. So like it is start, click start, and you can add from here. If you want to remove, you can remove from here. So you simply just double click the design, go to tag, and add your tag, what you have created for that. Okay, done. Shall we run this? Before I run this, lastly, text whether you understood something about this or not. Obviously, it is very fast. It takes time to learn, but those three things you have to understand, that design, driver, and tag. These three things are required. Okay, so once everyone tell me, how are you? You are present or not? Is it okay?
Yes, sir.
Very nice, very nice. Okay, so finally I shall run this. See, this is the run option. You will have different option in different brand. So I do this run here. You see. Actually, my machine has already been running here. So it is showing you the things running. So first I shall stop this. I have stopped it. That is stop there. It is because of Zoom. Because of Zoom, it is getting hacked. Okay. See, it is blinking here, but it is not running actually. It is off. Everything is off, but it is showing you the things running. Show you. Okay. It got some issue. So here, first I need to give a preset value. Like I want to give here, suppose 4 seconds. Here I want to give 6 seconds, and here I want to give 7 seconds. So I have entered here the value. And you see, I have created 2 screens. So I can go to main screen. I can go to timer screen. That is it. So we are in main screen. Now, if I press the start button, wait, program is in PLC. Driver is already given. Let me check once the tag I have given or not. Right, correct. and driver is comport number 3. Tag is green. Read error, write error. Okay, it is not communicating actually. Let me communicate first. Let me communicate first. See, now it is okay. Can you see this read write? Okay. So my PLC was not connected. Now it is okay. So your tag is being connected. And in tag, you see important thing. In tag, you have to give your driver, like this green is for which PLC. So I have Mitsubishi PLC, I have given. If I have multiple PLC, I will have to select my driver here. So in tag, driver is important. So it is done now. Now I go for its execution. See, so I have given here value 5, and here I have given 6, and here I give 7. Okay, done. So this is the stop button, and this is the start button. Now I shall operate machine, and in SCADA, because SCADA will be far from the workstation, so there it should be displayed. So when I press stop button, first we shall check stop button. Can you see? Can you see everyone? I am pressing stop push button in industry. In field, you can say. So I have pressed stop push button. You can see it is working. Now I shall press start button, you see. But it won't run. First see the push button. Can you see start push button? So in your field, on work station, if push button is pressed in control room, SCADA control room, it can be displayed. It can be monitored. But you see, when I press the start button, red lamp should get on. Why is it not on? Can you check the SCADA screen and can tell me why is this red not on SCADA screen or in machine? So what will happen actually, practical thing I tell you. Operator will press start push button like I have shown you just now. And machine will not start. Red lamp has to get on. It won't start. He will call the control room or maintenance department. He will call, and maintenance people first will consult to the SCADA room and will ask, see, start is pressed, but this red lamp is not getting on. So SCADA people will check on SCADA screen what might be the problem. Can you people check on SCADA screen that when I press a start button, red lamp is not getting on? Why is it show? So can you check that on SCADA screen? Everyone check that and tell me. Why is this not on? Anyone? Can you read the message text display? Can you read the message on text display on screen? Can you see that? What is the message? Sensor status. The sensor status, you can see it is off, isn't it? So in SCADA room, they will check, okay, they will say, see, your sensor is not on. So they will just go to the sensor maintenance people and will fix it. Is it on now? Is it on? Can you see? When I have put one metal to the sensor, now sensor is on. See, if the sensor is moved from its position, it is off. And in industry, because of machine vibration and all, most of time, proximity sensor will create some problem. So its position, I again fix. Okay, now it is on, sensor is on. Now in industry, on field, operator will press a start button and you see red lamp is on. And here also you can see it is on. Now all three I shall show you. You can see here. Can you see green is on? Timer is also running on the SCADA screen. All the things you can see. I have created logic for repeating the process, so it is getting repeated also. You can see, right? So this is your field, and on your screen, it is your SCADA control room. You can say you are sitting in one control room, SCADA control room. So it is being done. Now you see very fast, in 2-3 minutes, I shall finish. If I change this and I stop, you see one more thing. SCADA we use, first let me stop it. Okay, it is stopped. SCADA we use where we have tough conditions to put the operator, like it can be water, mud, or radiation or high temperature. Then the machine can be operated from control room itself. So now I shall operate these outputs from control room. Okay, so this control room SCADA. Now I press start from here. See, done. So red is on actually. Red is on, then yellow is on, and it is green. Green is on, and can be stopped also. And you see, if I make it 2 seconds, 2 seconds, you see 2 seconds, 2 seconds, and 2 seconds. And now I press start, you see, in 2 seconds only, it will change the status, isn't it? You can see on the timer accumulator also. In 2 seconds, it has been changing. Done. I hope you understand. So I stop the things. Yes. So finally, if you have any question, because I have seen that people have no question because all are very intelligent. They understand all the things in one attempt only. It's very good. So if you have any question, you can ask me. And further also, I am connected to the group. You can save my number and you can ask question anytime. You can contact me if you have any doubt in PLC, HMI, SCADA, drive, analog, in all these things. If you have any problem, you ask me, and I would request you people to conduct offline sessions if possible in your college. Then I shall come with all the systems and will train your students and faculty with real-time projects. So I hope you people understood something, but today response was a bit less. Yesterday it was very interesting. Although today topic was also very lengthy, so might be people did not respond that well. But very thank you for your patience, and thank you very much, sir, for giving me this opportunity. Over to you, sir.
Thank you very much, sir. Participants, any participants have any questions, please ask. Thank you, Himanshu, sir. Basically, we all are from the mechanical background.
Yeah.
Some faculties are from the electronics and the electrical. So because of that, it is very difficult to us that you whatever have teach today and day before. It was a very fantastic session, I think, and we get a value added sessions actually, and I'm very thankful for this. Definitely, we are arranging your session physically also, because this platform is not so much powerful to get the 100% knowledge. Okay, so definitely we think for the physical sessions also. So thank you very much for this value added session. Thank you, sir.
Thank you, sir. Thank you, everyone. Keep in touch, please.